Today we're going to talk about Hierarchy, the software tool that we've been working on for quite some time. But before we begin, I thought I'd introduce myself. So I'm Peter Joe, head of development of Hierarchy, and also the owner of Unconventional Thinking. And I have about 15 years of software development experience. I started back way in the 90s at Microsoft as a lonely software intern, back when Microsoft had crushed all its competition ruthlessly, which is a bad thing. And I've also been doing research in software architecture for the past several years. And for the past 5 years, I've been running Unconventional Thinking. And then for the past 4 years, I've been working almost exclusively on Hierarchy, except for about a year stint where I worked on another project at another company. So, today's talk. First, I'll introduce you to Hierarchy. We won't go into a lot of detail. We'll just talk about just the high-level concepts. It's probably not worth it to know the details, but I do want you to gain an understanding of how it works. In the second part, we'll talk about the benefits of working with Hierarchy. And I think this will be especially interesting to almost everybody. Hierarchy is obviously a very specific product. And in this part, I'll talk to you about specific techniques and specific architectures that we gain through our research and through our product development that is useful across all types of software development. And in conclusion, we'll talk about the future of Hierarchy. Hierarchy is a pretty unique product, so it really has the impact, the potential to make a huge impact on the system, or on programming in general. It could drastically change Java and drastically change programming in general, or if there's no user adoption, it could have very little impact. So we'll just talk about that briefly. And this is kind of somewhat related, but in our research on software architectures, we came up with a very novel architecture. And it's really useful today. And it's kind of very dear to our hearts. And I don't know if we'll have time to go through it. So what I'm going to do is that at the end of the conclusion, if people are interested, they can stay to hear the talk about n-dimensional architecture. If they're not interested, then we just don't need to do it. It's okay. So part one, introduction to Hierarchy. So what is Hierarchy? Hierarchy is a metacompiler that extends Java with new keywords and operators for working with hierarchical data. So that's a mouthful. Here's I hope everybody can see that, but that's just hierarchy code. And if you notice, it looks just like Java because it is. It's really just Java that's been extended. It has a class, a method, print statements, but it has extra code for working with matrices, which is Hierarchy's version of hierarchical data. So just think of it as an extension to Java, like as if Java has now gained new keywords and operators. But we don't call Hierarchy a compiler. We call it a metacompiler. And the reason we call it a metacompiler is because we take an embedded Java file, a Java file that's embedded with the new commands for working with hierarchical data. As you can see, this bold code is the code that's from Hierarchy. And we pass it through the Hierarchy metacompiler. And then what we get is a Java version of that code, a pure Java version. So it's really doing translation, similar to the translation you see in Perl, where it translates from the Perl language into pure C, or into, if people know CoffeeScript, CoffeeScript is taking an extended JavaScript syntax and converting that into a pure JavaScript version. This is the same idea. So as you can see here, it took this hierarchy code and turned it into just a myMatrix object accessing a get method. So it's really just a translation technology. But what does hierarchy add to Java? Hierarchical data. So what we mean by hierarchical data is XML or JSON. That's hierarchical in that it has a tree structure. A way we like to think about it is hierarchy is like as if XML had been incorporated directly into the Java language. So, as you can see, XML has direct correlations to hierarchy file types. The .xml file is equivalent to the .matrix file in hierarchy. The .xsd, which is a schema, is equivalent to a .schema file. And the .xsl, that doesn't have a direct equivalent. It's actually a little different. An XSL is, if you remember, its own language for manipulating XML data and querying it and filtering it, whereas a mjava file in hierarchy is what you saw. It's a Java file with extended instructions for accessing matrices and working with them. So I know some of you looked at the documentation and at the website. So you might remember this example. We're just going to go over it briefly for those that haven't. What we're going to do is we're going to create a home page for a website, for the Willie's Pet Store homepage. And we're going to create a news feed that displays the current news items for the homepage. So we're just going to do two of them, adopt a pet and 20% off, fanciful dog spread. So what we've done, and if you can't see the code, I put it on the handout, so you can flip to the handout if you want to. What we've done is we've taken the two news items and we've put those inside a matrix object. So think of it as if, in terms of XML, it's just as if we had placed the news events inside an XML document. And as you can see, the structure of the file is very similar to XML. It has a root node. Willie's petstore.content is the root node. And then it has one child node, news. And then inside the news node is multiple news story nodes. So if you know XML, you should be able to follow the structure of hierarchy and matrices really quickly because it's the same thing. And just if we look at here, inside the news story, we actually don't call in XML. We would call these tags. That'd be the news tag. This would be the news story tag. But in hierarchy and matrices, we call them descriptors. And in XML, we have attributes and values. But in hierarchy, we call those field sets with field values and field names. So here, that's where you store all the field values for each descriptor. Now, does anybody, can look at your code, does anybody notice a major difference between matrices and XML? Something that seems like it's missing. Right. So he said, where are field names? That's exactly it. Usually in XML, you would have something like date equals, and this would be the date. Title equals adopt a pet. Content equals your choice for your chance to adopt a lonely pet is right around the corner. But in hierarchy, you don't need to do that. You determine the field name by the position of the field value inside the field set. So the first position is the date, the second position is the title, the third position is the content. And you define that relationship in the schema. Here we have a schema. Oh, yes, go. So he asked, what happens if you have an optional field? So there are two ways to do it. One is you could just set that field to null or default value if you use primitive types. Or you can also do the XML style of attribute equals value. That's available. But what we've kind of found is that in a lot of cases, especially in data that's very dense, you actually do use a lot of the fields very often. Use maybe like 90 to 80% of it. So that's why we also provided it this way, because now the syntax is much cleaner, much simpler. You don't have a lot of extra text. But that also implies that for matrices, you have to have schemas. You can't not have a schema like you do in XML, because there is no field name. So you would define each of your descriptors inside the schema. And this is kind of the tricky part, but we worked really hard on trying to make schemas as easy to create as possible. And it might look it's a little non-standard, but really, once you understand it, we found that creating schemas, you can just do it in 3 or 4 minutes, as opposed to maybe like 10, 15, 20 minutes for a complicated, or even a simple schema.
I'm curious, look at the schema, how is it different from class definition?
I'm sorry, what's that?
I'm trying to see exactly the difference with class definition. I mean, to me,
Oh.
it reads like class definition, right? I mean,
So
say,
his question was, how is the schema different from just a regular Java class definition? Because it looks very similar. It's different because it's very similar, you're right, but it's hierarchical. Its structure is naturally hierarchical. So that's a good question, because if you looked at the matrices, news story elements are always going to be contained inside news elements. And to define that relationship in a schema, you would do the same thing. You would just put the news story descriptor definition inside the parent news descriptor definition. So now you've defined that relationship very easily. And that was one of the goals. Like, it's sometimes looking at an XSD, it's very hard to tell what it does, and very hard to tell what the structure of everything is. So it just seemed more natural that you could find out the structure just by looking at what the position of the elements are. Now, one of the main differences, or one of the main things that you have to pick up on in creating schemas is that, like the matrices, you define things in sort of a row column format, so that you define first all your field names, the date, the title, the content, and you define it just like you do in the matrices, by position. And you define the type in a nested descriptor, again by position. Date, string, string. Sometimes people take a little while to pick up on that, but that's the major difference. So, yeah, it's on your handout. Does anybody have any questions on that? Yeah.
In wanting to look at this, or one of your goals is that it's supposed to be a more visible schema? It's supposed to be quicker to comprehend?
It's exactly, so his question was, is one of the goals of the schema, is it so you can intuitively, visually look at it and understand it? Exactly. So you can just, I hope you can see that once you understand the format, it's very easy to understand what the definition is. You don't have to work through a lot of different syntaxes, and like an XSD, sometimes I can never tell what it really does. So yeah, since schemas are a required part of matrices, we really worked hard to make them very simple to create. And we have created real products with matrices and schemas. And we did find that creating schemas really do just take, schemas in XML can take hours, but in matrices, they really only take about 5 minutes. This would probably take, about 5 to 10 minutes to create. Any other questions?
Is there a reason you're following the row column format as against describing each field completely?
So he asked why, I'll phrase it a little bit differently, but why are we defining things in a sort of non-standard fashion where we do the row column format instead of just taking a field and doing all its definition? And the reason is because the first is because it sort of mimics the structure of the fields in a matrice. So it has that same relationship of being positional to define things. So that's a nice intuitive way to understand your schema and your field set. The same relationship. The second is because we also found that it's much more flexible for if we need to add new elements to the schema. And actually that does happen. So for instance, at the bottom of the schema, let's say you want to add a new type of way of classifying the fields so that you want to specify how it's used in a database, like database column type information. You can actually add that directly into the schema by just adding a database type info descriptor right into it. So it allows for infinite extensibility. So, these are the different parts of the schema definition. I think we all understand it now, but this is a descriptor definition, and that's a field set definition. How do schemas work? I think most people have caught it. That was a great question, because, right, in a matrice, I don't know if you can see this, but it's on the handout, but right, the first position maps to the first column of definitions in your schema. The second to the second column, the third to the third column. Does that make sense? That's the major difference. Yeah? Okay. So now let's take that code, those matrices, and we'll create a console application that will loop through the matrice and print out that information, that news feed, but it'll do it to the console instead of to an HTML page, just for simplicity. So this is a special file, the mjava file, which is just an extension to Java. And as you can see, it looks just like Java, and it is. It has a package, it has a class, it has a main method, print statements. The main difference is now it has these extended commands for accessing and working with matrices. So here, what we're doing is we're accessing that matrice we just created, the willie'spetstore.content matrice, descending into the news node, and then grabbing all the news story nodes inside the news node. And see this special filter right there means that we're grabbing all the children inside at that level. And then we're taking the result that's returned is just a regular Java collection. So you can iterate over it using just a regular for each loop. So the descriptors that are pulled out of that collection can be set to a special descriptor variable that knows where it is in terms of accessing that matrice. That's what this is. It's describing where it is in terms of that access. So that now we can use this descriptor variable in mid-access and start getting the field values and printing them out. So here's the title, the story date, the story content. So was there a question? This is a little bit of interesting syntax that is kind of a detail, but it's kind of something that kind of indicates what we try to do with hierarchy. Annotations. Now, don't confuse those with method annotations and class annotations. These are annotations that are specific to matrices. And what it is that if you notice, there's no exception handling, there's no null checks. I don't know about you guys, but I think that all the try-catch blocks, all the null pointer conditionals, it really starts to mess with the code, and it makes it very difficult to read. So instead, whoops, what happens here is if during one of these accesses, if there's a null pointer, if there's an exception that's thrown, instead of getting passed into a try-catch block, it gets passed to this annotation handler that will do all the processing. And if you want, you can define, this is a default annotation handler, but you can define specific ones on these accesses using a reference notation. And inside the annotation, you would also have a matching annotation handler. Yep. Any questions? Yep. So that's just the output. That's the actual output of that program. Not much to say there. Okay. So it's the end of part one. So we've created a pretty extensive document that describes all the features in much more detail. We worked really hard. I think that's part of our mantra, is that we believe that sometimes open source libraries, as wonderful as they are, the coding is so much work that they don't have enough time for documentation and polish. But we really want this to be adopted and used. So we've spent a lot of time on that documentation. So, if you use it, please read it. And give feedback too, because we're always trying to make it better. And is there any questions so far? Oh yeah.
So can you go back to the previous slide? I can't see that for the date output you have there, it's just a standard date output. Is there a way to change the formatting of that so that it doesn't look so machine-like?
Yeah. So his question was, in this output, it's displaying the data in a very, machine kind of system-like way. Is there a way to format it? Yeah, that's a really good question, because if you look back at the matrices, another major difference between XML and matrices is that matrices can have they are Java. There's no difference. I mean, it understands Java, so you can put real Java objects inside the matrices. So that also means that on the flip side, when we print out the date, we can use a format, just a standard Java date formatting objects to format that text. But I didn't want to add it because it would add complexity to the code. But good question. So his question was, basically, can you include one schema in another schema? Is that right? At this point, no, and that is a feature that we're going to add. It's actually, we've already spec'd it out, but we just haven't implemented it yet. So his question is, like, if you have a certain, you're talking about fields or actual full tags and descriptors, or both?
Wait. I mean, to me, it's a class. I mean,
Yeah.
It's a structure.
Oh, can you subclass?
Not a subclass, just compose. It's a composition.
Oh, composition? That's similar to his question. Composition is a feature that we've designed for this, but we haven't actually implemented it yet. So it's still in the works. Because it is a very useful feature, definitely.
I have another question too here.
Yeah.
I'm looking at Java util data string.
Yeah.
So I read the string is Java len string, right?
Java.
Len string, the type java.len.string.
Oh yeah, right.
Yeah. Why is a different notation for Java util data? I mean, what's the difference between? I'm just curious.
Oh, so his question is, why is, for the type, this is defined as Java util.date,
Plus, and then there are.
but this one is defined as just string. It's just a convenience because string is used so often, especially in hierarchical data. So we decided that just as a syntactic sugar. Yeah, you could do it as java.lang.string if you wanted
And
to.
what does a plus mean?
So one new feature that we introduced into hierarchy is symbols. Similar to Ruby's symbols, but I think they're even more useful because they're actually they have a little bit of type checking that goes along with it. So the plus means that you're creating a new symbol and that you're not just using an existing symbol. So yeah, that's a really good question. So his question was, can you use like non-standard class types as types? Maybe a class type that you created. The answer is yes. It can accept any type of Java type. Yeah. So let's move on to part 2, which is the benefits of using hierarchy in your own systems. And this part is a little more general. It's not specific just to hierarchy. If you walk away from this presentation, you can actually use this technique in your own software architectures. Although it is kind of novel, so I think very, very powerful. Yes. So first, how is hierarchy useful? Think of all the different ways that we use hierarchical data in our systems. XML configuration files, database results returned from Hibernate and JPA. Although they're not really hierarchical, they're really more of a map. Actually, hierarchical data in matrices aren't really hierarchical either. They're really maps as well because they're just Java, they can also refer back to the different parts of the matrix. Spring and its injection dependency framework, web services. And these are just a few of them. And hierarchy can actually do all these, all with one technology. And in our belief, if you think about it, it can do all these really well because it is hierarchical data. Hierarchical data is the core to all these different technologies. And now that it's a part of the language, that makes working with all these different problem domains much, much easier. Oh, and JSON. So the current XML technologies like JAXB and JAXP, they work really well. So why don't we just stick with those? I've used JAXB extensively in my development career, and I do like it. I think it's relatively fast to create the XML to class mappings. But the difference between creating a class and using annotations and creating a mapping versus using a data structure that's natively defined in your programming language is an order of magnitude more simple. Think about that. You don't have to worry about file paths. You don't have to worry about spelling mistakes. You don't have to worry about, you don't have to search for missing tags and improperly defined annotations. The metacompiler helps you and catches a lot of those mistakes that you would make. And it won't let you use schemas improperly. If you start to use a schema that's not defined, it will tell you. If you try to use a tag that doesn't exist in a schema or is misspelled, it will tell you. So it sounds great, but in practice, it actually does work. I think that's one of the advantages also of strongly typed languages is that it lets you know when you make a mistake. And that's really the summary of the main advantage of hierarchy. Hierarchical data now is as easy to create as creating a class. There's no need for creating an XML, creating a schema, and then creating a JAX-B class and a mapping. It's all done in one step. Just create the matrix and create the schema. So why use hierarchy? It's really the best of JSON and LINQ. So JSON, for those that are not as familiar with it, is JavaScript object notation. And it's basically as if XML had been incorporated directly into JavaScript itself. And if you look at it, it looks like XML. In fact, the original designers of JSON were thinking of JSON as a replacement usage of XML. But if you talk to, I know we're Java programmers, but if you talk to JavaScript programmers, ones that do pretty much JavaScript as one of their main programming languages, they tell you that JSON isn't just a replacement for XML. It's become sort of the central data structure for their JavaScript subsystems. What they're starting to do is, actually they've been doing for years, is they create JSON objects and they collect all the settings and content of their JSON objects, or their JavaScript subsystems, and put them into these JSON objects. And what that does is it creates a central place where all the major things that change in your system are stored. So that if you need to make a change to your system, you don't need to search. Let's say you need to change the name of the registration form from first name and capitalize first and name. You don't need to search all the places that first name is used. Now you can just go to the central location, this JSON object, and make the change just there, because all the settings for first name are right there. It's a very powerful architecture that isn't really utilized in Java because we don't have a data structure like JSON to do something like that. And Microsoft LINQ, I know we're Java programmers, so LINQ isn't the most popular technology. But I hope we can admit that it is very powerful. And a lot of people describe it as a very elegant, very powerful way to access data sources. And I would agree. It makes working with databases and just other types of data very simple. For those that aren't familiar with it, it's basically as if SQL had been incorporated directly into a .NET language. As you can see, it has a from clause, a where clause, and a select statement. And it takes that result and it stores it into a .NET collection. Hierarchy can also encompass LINQ, and maybe do it even better because its results are not limited by SQL. SQL is a technology that was ideal for relational databases, of returning results that are not hierarchical. But nowadays, we realize that our data that we use is hierarchical. That's why we use things like Hibernate. It allows us to have data results that are extremely complicated with lots of different relationships. So in a way, LINQ is powerful, but it's limited. Hierarchy can combine the benefits of both JSON and LINQ at the same time. And it really does have a lot of potential because you think, well, LINQ was a major technology for Microsoft, and it really changed the .NET platform, and JSON changed JavaScript. But the the sum is greater than the parts, because now you have one technology, hierarchy, that can do both. And you can use it in situations that you would need both JSON and link to do certain activities. OK. So at this point, is there any questions? So Alexander's question was, what kind of effort would it take to add IDE support to hierarchy? And actually, it shouldn't be too great. It's not there right now. We've only created the main metacompiler. But IDE support, the main thing is syntax checking and syntax suggestions. And we've already created the parser. So we just need to integrate the parser into an IDE. But it's the next major, one of the next major pieces. So your question basically is, XML is a metadata, so that it can be used across all technologies, .NET, Python, Perl, whereas this technology is specific to Java, so it's limited, and it is limited. That is its major limitation. But hierarchical data shouldn't just be a metadata format, which XML is really designed to do. What we realized is that in between primitive types and classes, we were missing something. We were missing a simple data structure that let us create hierarchical data really quickly. When you have a JSON-like data structure in your language, you realize that you can create certain pieces of your system much more simply. So I guess what I'm saying is XML has its uses. It's a metadata format, but it's not integrated into a language. And technologies like JSON show that hierarchical data structures can make a major impact in how you program if it's integrated into your language. So.
Well, definitely, but why not just use JSON then?
So this is a good question. Why not just use JSON? Or, well, I'll even make it tougher. Like, why not just create JSON for Java, which has been created, but it's still just a library? And why not just add JSON directly into Java? Because JSON is not really designed, in my opinion, it's not a robust technology. It doesn't have types. If you notice that schema, matrices have schemas. And it seems like now, well, you kind of added more coding, more technology, another step that you need to do to work with these objects. Isn't that a disadvantage, right? JSON is much simpler. There's no types. But we as Java programmers need to do things like work with databases, and we need to do high performance activities. So when we can define the types, we can do things like, now we can still do Hibernate type mappings very quickly, because now we can map from the database type into the actual type in an application. But
libraries like JSON, for instance, like JSON, not J, but JSON.
Oh, JSON.
Library. Yeah, you pick up, you define a class definition, and you just stream through it, right? You just read JSON files.
Yeah.
Into Java objects on the fly, basically, without. It's very seamless in a way, right?
Oh, so this is a technology that I'm aware of. I thought, is it a library that takes JSON code and turns it into Java class objects? Is that what it's doing?
It's efficiently Java class objects based on the JSON documents. Basically, you just read them.
Oh, I see.
It's a streaming library.
So this is not a technology that I was aware of, but there's so many out there. There are a lot of computers. There's JSON, which is basically it's doing some type of mapping between JSON into Java classes. But again, that's another mapping technology. I don't know the specifics, but one of my friends said, well, why can't you just use Hibernate for a lot of these activities? But think about that. If you want to use Hibernate to do and store and create like a table with a fields column and a field value column, you don't get the ease of use that you do with hierarchy, where hierarchical data is directly part of your language. If you look at technology, in my belief, you can't think of technologies different than applications or products. Ease of use is a really important factor in whether things are used or not used, in my belief. So let me get this right. So in the schemas, he was asking, do the field types support, basically you're asking what can be put as a field type. And the answer is anything you use in Java, you can use as a field type. In fact, primitives are supported and complex objects are supported. And primitives was actually much more difficult to support than anything else. Adding that probably added about 20% onto the development time. But we wanted to make sure that, I think for this to be adopted, it needs to feel like a real Java data structure. And that's what it really is. It's really, when you see hi dog, the Java code that's generated by hierarchy, you see that the matrices are very simple. They're very lightweight. It is just, if you define an int, it really just is an int in the field set. So.
I mean, to follow up on what you said, I have my own custom type. You support those two, or?
So he's asking if you create your own custom type, is that also supported? Yes, you can define your own custom types. Right.
Thanks.
Yep.
So I'm curious to know, maybe running a little bit ahead, but does hierarchical models has serialization, deserialization technique?
So his question is, does hierarchy have serialization, deserialization techniques? The answer is yes, and you're kind of jumping to the end, so you're kind of seeing what's ahead. But so I'll talk about that later, which is actually an awesome question because.
Highlight some of the major challenges that you might have faced in building this technology.
So he's asking what were the things, the obstacles that I faced while developing this technology. I'll talk about that at the end. Actually, that is a question that I put in the QA. And I'll tell you what, I faced so many obstacles. It was extremely difficult. It was both emotionally and financially and technically pushed me to the limit. So his question is, all these examples have been just about reading hierarchical data. What about actually setting things constant or modifying it? That's a great question because, yeah, this is not XML. This is not static files. This is a new data structure for Java. So you can modify things. You can, in fact, there's a very simple syntax for taking a field and assigning a new value to it. So, right. Although we haven't supported final yet. Final is coming up. So his question is, basically we can't forget about performance. And that's right. Performance, that was really, so I said that 20% was added to development time because we wanted to support primitives. Because primitives are very lightweight and high performance. And so performance is a huge factor. And we try to make it almost like as if there was nothing in the way of working with the field sets and the descriptors. So that when you access a field, there's almost no overhead. It is just a field access, except for there's a couple if statements to determine certain things. But right, performance is a major factor. That's an excellent question. So it's I don't know if you're talking about runtime, but I'll address it in both ways. So he's asking so hierarchy is a translator technology that translates from metacode into a Java version. And let's say, I'm going to talk about one thing. Let's say you have an error, but it's not really an error in your metacode. It's an error in your Java file. Will the hierarchy metacompiler pick it up? It's half the time it does pick it up, half the time it doesn't. It's a really major feature because we work really hard to try to catch everything, but we don't. So that's a very good question. But it catches half the things and it doesn't catch half, so another half. So.
And runtime? I mean, if, I don't know, like one of those things you had there, parse.
Oh, does
date,
that,
whatever,
oh, and in
change
runtime. And in runtime, if there's an exception in your Java code, does that map to a line in your hierarchy code? At this point, it does not. But what we also have done is the hierarchy, the meta-compiled code is available. This is what CoffeeScript sometimes does, and Eclipse Extend also does, is sometimes it is necessary to jump into the metacode, the compiled, or the pure Java version, and try to find and map that to your own metacode, or to your own extended hierarchy code. And that seems like a very painful process, but really, especially because we try to make the generated code as easy to read as possible, and we provide comments and sort of indicated where you are inside the code. So let's move on, and then you can, because we'll just finish up. This is almost, we're getting very close. So this is a technique that we use with hierarchy. So let's say we're defining an online form, and it's a very simple registration form with first name, last name, address. So think about when you create a web application and an online form. Think about all the places in your Java application that you have to find that field. The database. For instance, let's take first name and last name. You've created a web form, and it has a lot of different fields, but we'll just, first name and last name, you probably have to create a table called user, put 2 columns on it, first name, last name. And then for very complicated applications, we often have to create a Hibernate config file and define the mapping between the fields and the Java class. And then you have to create the Java class itself, defining first name and last name. And then also usually you have a JSF page or JSP page or HTML where you also define the field again. That's 5 different places you define that field. So if you have to make a change, let's say you want to add middle name, you have to make that change in all those different places and make sure you don't make a mistake. Oh, and you also might have right, that's 5. You might also have JavaScript that has JSON validation technology, so you have to define the field there as well. So now remember, this is going to be supported in hierarchy, but right now it's just an architectural technique that you can use. You can use universal data definition to define the field in one location for all its different usages. So for first name, these first 3 descriptors describe how the technology or the field is used on the web, in the web form. So it's a required field. It's a text box with 30 characters maximum. And it has help text that once you roll over it, it says, please enter your first name. And then you can also define what the field value is in the database. The database first name is on the customer table with the first name column and it's a varchar. And you can also define what JSON object that this field maps to. It maps to the myJSON object first name. And what's nice about that is if you think about MVC architectures, I love MVC architectures. I've been using them for years. But one of their drawbacks is if you need to make a change, you don't know where all the different places you have to make them. You have to jump from the model objects to the action objects to the view objects to the control objects. This shows you exactly where all the different usages of that field are. It becomes a map to what this field does. And if you need to make a change, you only need to make a change in this one location. So remember, this is an architectural principle. It's just the technology that we're also working on. But what you would do instead is now you would automate the generation of these elements. So once you describe your web form, you can create a loop that will loop over the matrices and just generate the form dynamically. And it seems like a lot of work, but we use this in practice, and the amount of code that you need to do that is not great. And I know there's so many different slated technologies, but we're actually designing libraries that will generate that code for you. And we already have schemas that are already defined for generating forms. So is there any questions? This concept is a little, so his question was, how would you handle the aspect of internationalization, where you have to define multiple languages for the same text? So this is a simpler example. This isn't really realistic, but you could, in your help text, you could define schemas so that you could nest help text child elements that are specific to each language that also indicate what language they are affiliated with. So English and French and German. So it'd probably, inside help text, you'd have nested elements instead of just having it directly as a part of help text.
Oh, okay.
Yeah.
So technically we would be defining a schema for this as well, right?
So his question is, technically you would be defining a schema for this as well. Yes, and this is nice. You can define multiple schemas so that the schemas are reusable. So if you look right here, these are the different schemas that are used. The web form schema, the database schema, and the JSON schema.
So in that case, ace required would be some kind of a Boolean field. I mean, there's ace required value here.
Sorry, what's that?
You have ace required value, right?
Oh, right here?
Right.
So you're saying, this is just a detail, but for the form required field, that could just be a Boolean field, true, false. That's true. But there's one sort of design consideration when you use matrices that, since they don't have the field name, sometimes you want the field value to be indicative of what it does. So that's why symbols are so useful, because here it's indicating, this is a required element. Because actually in real usage, form required has more fields, like also indicates its path and the size of, indicates like the required image that pops up if it's required, and the size of that image and the path to it. So you just want you want to be more descriptive in your fields. Yeah. So his question was, and that's a great question. So his question was, if you create this matrix C, this web form, is the intent here that you would create code that would loop over it to generate, for instance, the database queries and database? That's exactly right. And in a Hibernate-like way, or whatever way you want. Like we actually created it created dynamically created SQL queries on the fly based on this information, is what we created. So his question is there schemas that can be used to do alterations on the database information, for instance, alter table or revisions? Right now there isn't, but that is simply a matter of defining that in a new schema and also creating the necessary functionality around that. So the question is, would you store revisions in that same schema? So first, this is a matrix.
That matrix, sorry.
Yeah. So would you store those same revisions in that matrix? I don't know. I mean, like I haven't really. That's a really good question, because would you want to clutter up the matrix? That's right. I don't know. Or would you want it to be the end result of what happened? Yeah. It's a very good question. Yeah. So his question is that you could still do all this with Java classes and annotations.
Yeah,
Is that
it
right?
will look probably
Yeah.
as
And the-
easy or maybe even, you know.
The question is, and the answer is, you're right. And you could just use, actually the first version of this, when we prototyped it, was just multi-dimensional arrays. Because that multi-dimensional array syntax is very easy for creating structures that look like this. So
No,
I'm saying like there's,
language features, not arrays, I mean, just usual Java language features. We just put, you know, add annotation.
yeah.
I mean, it's very different from going into arrays. I mean, I can, even if I think about arrays, that will be unreadable. But, you know, Java annotations are very readable. And they
Yeah.
Java docked, everything is
So,
nice and pretty.
well, so what we would do with multi-dimensional arrays is structure it not like a multi-dimensional array. We'd structure it like hierarchical data, so it would look almost exactly like the structure. But I guess what I'm saying is that, you know, you can use almost any technology. Like I was saying, you could use Hibernate to do almost all this stuff. But would it be easy to use? Would it be practical? And you're right, Java and annotations, Java classes with annotations is a pretty close parallel, but Java class is not designed for hierarchical data, and when you do use it, it doesn't really look great. It's not as readable. It's not as easy to use. It's not really designed for hierarchical data.
No, I agree with that.
Yeah,
Just like, again,
Yeah.
I'll keep arguing this point, but
Yeah.
what's not convenient is 10%.
Yeah,
And you're trying to replace 90%, that's actually pretty convenient.
yeah, yeah. I agree. There are a lot of parallels, and like there's a lot of overlap. I agree, absolutely. Oh, so here's a little question. Actually, most people don't get this. I don't think anybody's ever got this. So in universal data definition, you're defining how a field is used in one location. But even with this, you still have to define it twice. You have to define, even with universal data definition, you have to define the field in two places. Can you see what two places you have to define it in? Like you have to define it in the matrices, but there's one other location that you would still have to define it. Wow, a lot of people got it. Yep, it's database. So right, you have to define first name, last name as in the tables.
I thought that's the matrix. That was my question.
Yeah. So, but this is on the client side. It's almost more like Hibernate than it is like. So this question is, well, I thought that's what this database column was doing. Yeah, this is on the client side. It's more like Hibernate. Hibernate isn't persistence. Hibernate is object relational mapping. It's not true persistence. It's a mapping technology. This is doing the same thing. I know with Hibernate it has the auto-generate feature, but really it's a mapping technology. So, does it do auto-generation? Not at this point, no. But we have an alpha feature that has included persistence directly into hierarchy, so that it's true persistence. You don't do any type of mapping between hierarchical data and a database. A persistence server is included directly into hierarchy itself. And think what an advantage that is. Persistence can be sometimes quite painful to work with. Hibernate, you have to create mappings, config files, database connection, make sure all that's working. With this, you create a native data structure in hierarchy. And you don't even have to know if it's going to be persistent. In fact, we've done that before. We don't know if it's persistent, but later on we decide, oh, we want that news feed. That news feed, we're changing it on a daily basis instead of every week like we thought. We'll make that persistent and just create an admin interface into it so that we can change it dynamically on the fly. And it's that easy. Like, you start up the persistent server, make sure it's running, and anything you want to be persistent, all you have to do is, on that matrix, turn on a setting that says persistent, and now that matrix is persistent. Oh, it's a working alpha. It's another technology that, yes, like we're saying, there's so much going on. But hopefully the beta will be out in about a month or two. And that's the real power of hierarchy. It's one technology for multiple uses. So one technology is doing XML configuration files, Spring-like functionality, where it's collecting settings together, object relational mapping, which is different from persistence. Now that's mapping, because it is still important to map to legacy databases in our systems. True persistence. And think about that. So like we were saying, almost any technology, a lot of technologies can do double duty and cover a lot of situations. But this technology, it covers all these situations and does each very well, we believe. If you think about it, the reason is because the key to all these different technologies is hierarchical data. That was the missing link. Like, I think we thought that Link was a great technology, but it really missed it that hierarchical data is the central key to everything, and things should be built around that, not around querying. So, the future of hierarchy. Finish the beta 2 fixes. Finish persistence. Very important, like Alexander was talking about, IDE integration is extremely important. Ease of use, syntax checking, syntax suggestions. A view language. So this is just a minor feature, but if you want to create matrices that are views into other matrices, like view tables, this is a very useful technology. And you could also define it so it's either static or dynamic. Link, Hibernate-like functionality, again, also being developed. We already talked about this. Matrices are not static, they're not XML, they're actually dynamic data. They are actual data structures, so you can also assign values to them so that you just don't need to use them just like static XML. You can actually use them like a real data structure. And this is probably the biggest issue that we face, user adoption. If people don't use this technology, then it's pretty much worthless. This is the crux of everything. So we're trying to avoid creating code that's buggy and poorly implemented. We actually followed the Apple methodology as opposed to Amazon and Google, which I greatly respect. But we thought that we would try to polish it as much as we can and release it instead of releasing a product very quickly and just iterating. So a lot of time has been spent to polish the metacompiler. Tough to work with. Ease of use. This is a very intricate technology with lots going on, so we designed the language and the metacompiler to be very easy to use. Those are very key principles. And have supporting tools, IDE integration, very important. Oh, and it's not effective if nobody knows about hierarchy. So that's a very important aspect. It's not open source right now, but we do plan to release it open source in the future. This was a really difficult decision because it's been 4 years, 3 which were completely unpaid. So there's been a lot of financial and just a lot of time that we spent on this. So we actually weren't going to release it open source, but we realized that user adoption is the most important issue. So we will. But right now we're trying to work with open source companies to see if they'll buy our product, so we can at least pay off some debt. And this is only 30% of what we had planned for the product. For instance, we can't talk about everything, but we wanted to create an Excel-like tool so you can edit the matrices using an IDE. And if you think about that, I don't know if everybody's used this, but OpenCMS, it's not very well implemented, but the idea was great, is that XML config files are the heart of everything. And you don't have to create admin interfaces because you can edit the XML using a Excel-like editor. So I think the same thing could happen with matrices. We're also planning on creating new architectural language elements. So extending hierarchy to support, we support higher level architectural constructs and then integrating that into the IDE. And then this is just more of an interesting one, not a great technology that will change much, but replacing JSPs with a new tool that translates, that doesn't have to just output HTML. Well, JSPs don't, but isn't just creating HTML, but can generate anything. So you can use a JSP-like language to generate Java or COBOL or whatever. So that, because there are situations that we found that if you do want to create very optimized code, you can generate really streamlined, optimized Java code using technologies like this. And what's more high performance than code that's specifically custom designed without any Hibernate layers and all these layers that are working with it? It's very high performance. So here's our message. Contribute your time, please. Because as you can see, there's so much work that needs to be done. It's really at a crucial stage. If you don't need to know compilers to work on this. In fact, compilers is probably only 10% of the work that you need to do. So we just need good developers. And I think, I hope you see that the people that have joined on this project, they understand that this technology is at a point that it could really change Java. It could really change programming in general. We think that it has a potential to have a greater impact than Link and JSON did on their technologies. And we feel that they had a great impact on their technologies. So thank you for your time.
First of all, I just wanted to thank you. I appreciate it really for this amazing talk.
Oh, thank you.